Welcome everyone to the Portland Public Schools' third annual STEM Expo. It's great to be here today. My name is Javier Botan. I'm the superintendent of schools here in Portland. And although the Expo is a bit of a tradition already, I'm new here, so this is my very first one, and I'm super excited to be here. I'm looking forward to touring all of the exhibits here today and seeing our students as they showcase their learning in the areas of STEM. And I'm pretty sure that everybody here knows what STEM is. It's science, technology, engineering, and math. And it's really one of the most incredible opportunities for our children. And so very, very excited to be here today. About half of the approximately 50 exhibits that we have are put on by our students in all grade levels here in the Portland Public Schools, elementary, middle, and high school. The rest of the exhibits are put on by our valued community partners that help to make this expo a success each year. They include exhibitors from local colleges, universities, and businesses. I'd like now to introduce representatives from two of our key partners in the expo who will be talking to you about their involvement in the importance of STEM. Before I do that, though, I would be remiss if I didn't recognize some of the staff from Portland Public Schools that worked very hard to pull this together. So I'd like to particularly thank Kathy Cole and Tina Mickelson. This is a tremendous undertaking. There will be over 1,800 people here at some point over the course of the day, and so coordinating all of that takes a tremendous amount of work, and it wouldn't be possible without Kathy and Tina, so thank you guys. I also want to recognize Becky Dorr. Becky is probably running around doing something right now, but Becky works directly with Jeannie Crocker and is an incredible part of this team, so thank you, Becky. So now I'd like to introduce the first person that is one of our partners, and that's Dean James Graves of the University of Southern Maine. USM not only has exhibits here today, but they've also worked closely with us on the logistics of making sure that this event runs smoothly. Dean Graves is the Dean of the College of Science, Technology, and Health, and he's a professor of exercise, health, and sports sciences. His research topics include the influence of physical activity on aging and resistance training for the prevention and rehabilitation of orthopedic problems, including one that's near and dear to my heart, lower back pain. So with that, Dean.
Superintendent, thank you very much, and you're not the only one with back pain. 80% of all individuals at one time or another in their lives will have that problem to deal with. Good morning, everybody, and welcome. Welcome to the University of Southern Maine's Portland campus for the third annual Portland Public School District STEM Expo. As the superintendent explained, STEM stands for Science, Technology, Engineering, and Math. And it's not only responsible for how things get made, but it's responsible for explaining how the world works. And so we think it's pretty important. I'd like to thank all of the exhibitors here today for sharing our commitment to educate students in this area. Students today have a lot of choices with respect to where they can study STEM fields. And at the University of Southern Maine, we cover not only the basic sciences, biology, chemistry, physics, but mathematics, mechanical and electrical engineering, a couple of disciplines in the computer sciences, technology, environmental science, as well as sports science, which, as the superintendent said, is near and dear to my heart. I've also noticed some of the 1,800 students that will visit us today are already here, so welcome students, you're in for a great day. This is so much fun. I also can't wait to tour the exhibits. Welcome and enjoy this beautiful day in Southern Maine. Thank you.
Thank you, Dr. Graves. Next, I'd like to introduce Bill Welch, who's the President and CEO of InViral. InViral is a local biotechnology company, and they're huge sponsors of the STEM Expo with us every year. This is our third year with the STEM Expo, and they've been our lead partner for those 3 years. Funding from InViral helps to make this event possible, and our students always enjoy, right behind me here, the company's exhibit on its work around food security. Bill joined InViral earlier this year. He actually predates me by about a month. And his previous experience included working for EBI, the Danaher Corporation, and Eaton Corporation. Bill?
Thank you, Javier. I'm proud to be here on behalf of InViral. It is my first expo, but in addition to representing InViral, the funding for today's program, as well as additional grants that are able to be brought back into the public school system, are done on behalf of our foundation at Ensign Bickford Industries, and I'm proud to represent them as well today. STEM is critically important to us at InViral, as we are a science and technology company based here in Portland. And over and above just beginning that spark of interest for students in the STEM programs, we have a selfish interest, as we currently have about 100 employees here in Portland, but we are growing by leaps and bounds, and we fully expect to be doubling and tripling in our size, and we need talent. And we're hoping that through these programs, we will identify talent and attract individuals to stay in the Portland area and help InViral grow and continue to give back to the community. So again, on behalf of InViral, welcome everyone. Thank you to the students, and thank you for the other organizations that are here today to really showcase what STEM can do for our students and have fun. Thank you.
Thank you, Bill and Dean Graves, and a heartfelt thank you to everybody at USM and InViral for their involvement in the STEM Expo. A great city is made up of great schools. Great schools are made up of great children and great teachers, and you're going to see examples of all of that here today. And those great schools happen because of the partners that work with the school system to make that a reality. So this wouldn't be possible without your partnership and support, so I really want to thank you for that. We all know how vital STEM learning is for our students to be able to succeed in college and career in the 21st century. That's why STEM learning in the Portland Public Schools begins at the elementary level and goes through high school. And it's so great that USM and InViral are collaborating with us to show our students how important STEM is beyond high school, in college classrooms, in research labs, and working for businesses like InViral. I'll also take a moment here to mention the other community partners joining us here today as exhibitors. They include the University of Maine and the university's 4-H STEM ambassadors, the Maine College of Arts, the University of New England and Southern Maine Community College, Engineers Without Borders, Kepware Technologies, Learning Works, Challenger Learning Center of Maine, ACE Mentor Program, and the Portland Public Library. You know, in addition to the students exhibiting here today, as I've said before, we'll have busloads of students touring the exhibits. In all, we expect about 1,800 visitors to the Expo today. Thank you very much again to InViral, to USM, and to all of our partners for doing your part to open our students' eyes to the exciting possibilities in the world of science, technology, engineering, and math. Thank you very much.
Hi, my name is Audrey Watson, and I'm from King Middle School, and I'm in 8th grade.
I'm Tira. My name's Tira Pranger. I'm also in 8th grade from King Middle School.
So our expedition is about using renewable energy and reducing climate change. And so the main renewable energy that we're working with is wind energy. So we're creating windmills to produce electricity without burning coals and emitting fossil fuels.
So here we have like an engineering and design process. We kind of looked at previous windmills that King students created and like how they worked and how they may not have worked. And so these drawings were all sketches of how we represented that. And we also have here, we've been working on this app called SketchUp, and people use it to like we used it to help to like show how we designed our windmills. So here is like the base, and you can see how like the whole structure of the windmill.
So as you can see, under the base there is kind of like platforms for studying the windmill and the base, and then on the edges we have noodles so that there's like buoyancy there to help it float, and then the tower made by PVC, and then we have plastic blue wind blades, and those are going to be curved to help catch the wind a little more than just flat wind blades.
Yeah, so over here we have, actually it was yesterday, pretty sure, or the day before, then we created these. And these are kind of like these are like a smaller level to represent what we're building now. It's kind of we did this to like help us understand like how like the flotation works and how like sturdy it is. So we created these with minimal materials. This is one that I created. The base, they said that the base had to be like half the size of the spar. So this is the spar, the thing that holds up the wind blades. And so that's what we did a couple of days ago, and we tested those. And this bucket of water, there's no water in it right now, but we still tested it to see if they were sturdy.
So this was just kind of like a trial and error sort of thing. So like we could see what would work with our windmills and what wouldn't. So like you had the spar here and the windmill. So I'm gonna just take this one for example. Oh, okay. So that's okay. So we had to use under it, you can see, is the rest of the spar, but that's called the ballast to help the windmill and the base kind of steady a little bit more. And you could also see that on the SketchUp that we had. So yeah.
Okay, so as we move over here, we have the rest of the King students. They're kind of creating wind blades. This is a design area, so we're kind of like experimenting at the same time showing you guys what we're doing, because we're still building our wind turbines for the expedition. And then
so that's sort of like to know what kind of design for the bigger one. So this is also a testing area where if we build the windmills or the wind blades, we can see how they test. And we also have a little light bulb right there. So if it seems to be working, it does, it will light up, as you can see. So we have Evan Hopla here and Riley Johnson testing their wind blade turbine ideas. And the spar and the base of this, that was just kind of a testing one, not one that we built. We're going to build our own towers or spars and the base. And it's also going to be floating.
all right, and then as we move over here more, we have, do you want to work the fan? So we have this is an actual offshore wind turbine that one of the King students created. And so you can see how this is called the spar. They didn't create that, but they did create the base. And theirs is really stable. I'm pretty sure they went to the USM in Orono, and they tested this, and they actually got like second place, I think, or was this or another one. So yeah.
So in this this little area right here, the container, there is like a motion sensor. So on this iPad that Evan is holding right here, it shows you, like, if I move it like this, you can see the motion sensor is picking it up on the iPad and moving up and down. Go ahead. So there are Y-axis and X-axis. So if it like moves up and down or side, it's like if you have a side like this. like if it has a big plop down, you can see there. So if that, it could also work if it's like out in the ocean and you can't see it because it's like miles away, then the motion sensors on this iPad would help you figure out how much it's moving. So, yeah.
All right, so my name's Ella Raymond, and this is Emma. This is Meg.
Hi.
And so our project was on rising sea levels. And the reason our sea levels are rising is because humans are burning fossil fuel, and that releases CO2 into the atmosphere. And when there's CO2 released into the atmosphere, that gets trapped, and it like acts as a layer for the heat, and it keeps all the heat in, and it warms up our sea levels. And we related like thermal expansion of water, which we were doing in our classroom, and we went to like to see how our oceans were rising. So we went down to the ocean and we took a sample, which is right there, and it's slightly warmed because it's been sitting out for about a week. and then we put it in one of these like beakers, and we put boiling water underneath it, and that slowly warmed up the seawater, which is colored black, so you can see it go up this straw. And then we would mark it every 10 degrees on the straw as it expanded. And then we graphed it, and when we graphed it, we put a trend line into the graph, and we were able to find an equation for how our sea levels are rising. And then we took that in relation to an Olympic-sized swimming pool, and we found at what temperature the Olympic swimming pool would overflow. And then we showed sports apparel. Well, Attain, which is right here in Maine, that rhymes, it provides materials that are right here in the US, and they use 40% renewable energy, and they do a really good job with that. So basically our project was to show, hey, our sea levels are rising, try to take initiative and try to get to stop rising so we can have a safer planet.
Hi, my name's Maria, and the Asiatic bittersweet is tearing down our trees.
Hi, my name's Matthew.
Hello, my name is Theo.
Hello, my name's Pepito.
Hello, my name's Abdakani.
Hi, my name's Talia.
Hi, my name is Zachariah.
And we had our project is Asiatic bittersweet. Asiatic bittersweet is a vine that strangles trees and wraps them up like this one. It just grows like a beautiful little berry, and then it just turns into a vine that destroys a lot of trees.
Well, when the pigeons or anything eat the berries, they poop out the seeds. And when they poop out the seeds, they make more Asiatic bittersweet go around and around a lot of places.
It was introduced in the 1860s because of its beautiful thing. You could wrap it around houses and make ornaments. It's used for landscaping purposes of beauty.
It has recently been discovered in Rhode Island and Connecticut.
I'll do it. Asiatic bittersweet is like a vine that grows a perfectly little berry. Then it finds its natural tree and wraps around it until it gets all the moisture out of the tree, and the tree ends up dying, because it forms a perfect loop around its prey. It's like an anaconda that circles a prey. But this is a tree that comes out of nowhere. You think it's a beautiful little berry and you want to plant it in your house, and it gets your trees and just circles it and circles it.
It is killing the forest, which means it is killing the oxygen, which produces the oxygen that means less oxygen. the Asiatic bittersweet comes from the top and the kudzu comes from the bottom. When the kudzu comes from the bottom, it comes up and the Asiatic bittersweet comes down, and then they get connected, and when they get connected, they wrap around the trees and do really, really bad things to trees.
25-year-old Asiatic bittersweet is about 4 inches wide. It grows around other vegetation. It has invaded the deciduous forest behind our school, and it is killing the trees.
A vine can twist to support itself up to 30 feet long. Leaves turn yellow and fall.
It's recently been discovered in Rhode Island and in Connecticut.
It's killing the forest, which means it's killing the trees, which produce oxygen. That means less oxygen.
The vine Asiatic bittersweet is strangling trees in the deciduous forest of Maine. Where did it come from and what can it do? Can we do?
Good job, you guys.
My name is Theodore Burke, and I am working on the project that there's trash flows in the ocean that are causing various problems with our oceans, because as you can see in the Pacific there are trash flows, and a few years ago it was the size of Rhode Island, and now it's the size of, I think, Texas and California combined. That's a big trash flow in the ocean, and you can kind of see here, this is where most of the trash is combined here because of the current in the ocean, and because of the current it's combining into one big circle, and that is causing it to bind together in a massive, like, almost like vortex of just trash, and it's suffocating all the animals, because when the animals come up to breathe, they're trapped by the trash, and it's killing all our animals. And so I came up with a ship that would clean up all this trash. So basically what it does is, you can see here, it sends out a probe that goes down in the ocean and sends out a sonic boom that, like, basically detects the trash, and then the ship gets a sonic rating from that probe in the satellite dish, and then it heads to that location, and then it sends out these two spires here send out massive ropes as well, supporting the probe to go down into the ocean. It also supports massive tightly compacted nets that fly out into the ocean and basically rally up some of the trash, and then brings it in and then tightly compacts it and crushes it, and then it's go back to the shore and unloads that compacted trash, heads back out, keeps doing that till the trash is fully gone in one area, and then we'll bring the probe back and head to another area where the trash is, probably around here, and then they will send out the probe and repeat the process again.
Hello! Welcome to rocketry! So here we have all the materials. Hi, sorry, I forgot to mention my name. I am Richard Biggs. And here we will be teaching you about rocketry, like I said before. Here are all the parts we need. We have space tube, launch lug, engine block, body tube, wadding, which is not tissue paper, nose cone insert, nose cone, shock cord, streamer, shock cord mount. And then here we have the fins.
Hi, I'm Quinn, and Hall School last year did a project on rockets. So what we did was we would make the rockets. This is what the final product looks like. Some of the things we use are the spacer tube, the launch lug, the engine block, the body tube, the nose cone insert, the nose cone, the wadding, which is not tissue paper, the shock cord, the streamer, the shock cord mount, and the fins. We also, and we also have researched Newton's laws. The first law is objects at rest will stay at rest, and objects in motion will stay in motion in a straight line unless acted upon by an unbalanced force. His second law is force is equal to mass times acceleration. His third law is for every action there is an opposite and an equal reaction. And this is all of his laws together. An unbalanced force must be exerted for a rocket to lift from a launch pad. The amount of thrust force produced by a rocket engine will be determined by the mass of rocket fuel that is burned and how fast the gas escapes the rocket. And the third law is the reaction or motion to the rocket is equal to and an opposite direction from the action or thrust from the engine. And these are the different levels of winds that we would shoot the rockets in. A light air is 2 to 3, which smoke slowly drifts. So when it shoots, the smoke just kind of drifts. And a light breeze is 4 to 7. When the wind, like you can feel the wind, the leaves move like gently, not very much. And a gentle breeze is 8 to 11, which is leaves in continuous movement and flags flap. A moderate breeze is 12 to 16. Dust and paper blown about, small branches in motion. A fresh breeze is 17 to 21. Small trees and in leaves sway. Strong breeze, branches in motion, whistling in telephone wires. Moderate gale is 28 to 33. Whole trees sway back and forth.
And you need the engine over here behind everything. So this is parts of the engine. This is the engine. It's soaked in water, but be careful not to touch it because it still could have a little bit more gunpowder. Then there's the engine cap and the engine igniter, which you use to launch the rocket over here. It's not in right now, but this is what it would look like when you were ready to launch.
Hi, my name's Joseph, and I go to Deering High School. And basically what we have here is Mr. Borland and a lot of his students from AP Statistics and a lot of his other classes made this game called GameOn.World. And basically there's a map that shows up on the screen, obviously, and there's a place that pops up. And what happens is each student with the individual map guesses where the place is and hits submit. And if you're correct, kind of like what Caden's doing right now, if you're correct, it'll show how many miles you are away from the city. And there's a leaderboard, and basically what happens is you can have as many questions as you want. You can pick whatever you want for time length. And what you do is you basically just guess, and whoever gets the closest on all the cities wins. And it's a really interesting program that we made, and it was made just by Deering students, so it was a really good program. Also, you don't have to do just places. You can do sports, you can do entertainment stars, you can do things like that. They have a timeline as well, so you can pick like what year did the civil rights movement start, things like that. And it's just really interesting to see how much you know about our history and the places in the world and stuff like that. Yeah, and celebrities as well. It's kind of a really good way to learn about social and historical content. Caden, you want to talk about our NXT robot? A little bit.
So in a different class, robotics, we were building Lego robots to learn how to program and things. So we built this. It took us about a week to build. And it can do all sorts of things like follow a line,
spin in circles, move when you clap, and just all sorts of things. The robot responds to touch, speech, and just pressing an orange button. It took us about 6 to 7 weeks to program and 1 to build. The class was only 8 weeks, right? Yeah.
Here's your toe. There we go. So then that's a switch for this. If you step on it, it's supposed to work. When you step off of it, it's supposed to stop working. It gets stuck a little bit, and so we're trying to come up with a switch for this one. And all we're really working with here is the idea that, you know, the motor in your cell phone?
Yeah.
The vibration motor is, so this is a little vibration motor, and how it's offset. So we'll pull these out of some cell phones, and then we made a few little critters on this scale, and then started looking for other motors and how to offset them, like putting a penny here, or there's like a gear stuck on that. Figuring out ways to get stuff to jump around and run around. Just kind of messing around with stuff, see what we can come up with.
What would you call this?
The whole thing, or this small piece right here?
This is really cool.
This is the
Jack, you're so trash.
Wiggle box. Wiggle.
It's confusing.
These are offset motors. Hold on. Hey, Magnus. Yeah. You have to, if you pick it up and put it next the back of it, there's a speaker. It's hard to hear in here because it's so loud. But as you
I already heard it.
Oh, you already heard it?
I'll play it. Help me find my brother.
We were, hold on. Hey, which one am I? Hey, let me get this one.
That one is water girl.
Go on, restart.
Restart. You have to click the button down there.
Alex, switch spots.
Retry. And wait, don't click on it. Go over it, press the space bar. Ain't that cool? That's actually this part. That's actually part. What is this called?
Wait. So let's do this.
Guys have any questions? So it takes solid plastic, runs it through, heats it up, and then uses a computer system here, tells it where to go, and as the solid plastic's coming out, or as the liquid plastic's coming out, it solidifies and what becomes the hard plastic is. But as it's doing that, it's reshaping it. So instead of a conventional manufacturing where you take something and then you work it down, this takes nothing and works up. Yeah, it's 3D printing right now, so it's printing a panda that was designed on there. That's printed. All this stuff was printed.
What? Really? Yeah, so just like...
Yeah, the kids experimented with regular marble tracks like these, and then they drew marble tracks, and then they engineered and they tweaked them because they found that certain angles and things would